Today's lesson in class was about substitution method for systems of equations. So we started out with some basic things where we saw possibly where one equation was written in slope-intercept form, such as our first one here. And then for our second equation, we either had one of our variables equal to a number. On a few of the examples, I maybe gave you variable equals to, like for example, y equals 7x. So we saw a mixture, but just to refresh your memories on what's going on, all we're really doing with substitution method is exactly how it sounds. We're substituting. So the key things to remember, and some of the mistakes we had made that I think we learned from, we're making sure we plug in the right number for the right variable. So if this is y equals 7, I should be substituting it into the other equation for y, not for x, and vice versa if you knew what x was. We also need to remember our steps for solving. DCS, distribute, combine, and then solve using our techniques of getting rid of addition and subtraction first, then multiplication and division. So those are things you know from before. We're just putting it all together now. So if I see y equals 7, simple substitution, whatever y is gets placed into the other equation for y. So I would have 7 equals 3x plus 1. And I'm solving for x because that's my variable that's in here now. Just one variable left, that's what we want. Easy, two-step to solve. Get rid of the addition by subtracting. I'm left with 6 equals 3x. And final step, divide by 3. X equals 2. So the steps you wrote down today from the book show you that first we solved for one variable, we did that, then you would plug it in to solve for the other. In this case, we already knew what y is, so I could plug it in to the other equation to solve for y, but we already have the answer to y. So y equals 7, x equals 2, we would write our answer in an ordered pair form. Answer is 2, 7. We would check it by plugging in. I'll let you guys try that out. I'm going to skip that for now. Moving on to something a little bit more difficult. Here I have two equations, both written in slope-intercept form. Y equals 2x plus 4, y equals 3x plus 8. Something that I stressed was using substitution out of our three methods is easiest when we already have at least one of the equations with a variable isolated. So what that means is here we have y by itself on one side. Same here, but we at least have one equation where a variable is isolated. So substitution here would be a good idea. This is no different than the others. What's going to throw us off is there's a lot going on, but it's really no different than if I had y equals 3 and I were to plug that in, or if I had y equals 3x and I plugged that in. We're just plugging in everything that y is from one equation into the other. So what that's going to look like now is when I replace y in my first equation with what y is from my second, I have 3x plus 8, which is y, equals what's left, 2x plus 4. So I basically substituted that entire second equation into the y up here in the first. And I've made them equal to each other. That makes sense. If I know, for example, let's say that this is a basket, this top 2x plus 4 is a basket, and I know that it equals a certain number of apples in that basket, and I know that I have a second basket and it equals the same amount of apples, then this basket should equal that basket. That's the idea, okay? So now I'm solving it using DCS. Nothing to distribute. Combining, I have things to combine because I have x's on both sides. I don't want them on both sides, I want them all on one. So what I would do, it's a positive 2x. Let's subtract it out. I'm left with 1x over here. I'm just going to write it as x plus 8 equals 4. Subtract 8. It's the same as saying x, sorry, that's gone. That's the same as saying 4 plus a negative 8, which is negative 4. So x equals negative 4. I solved for one variable. Now I have to plug it in to figure out y, because I still don't know y. I'm going to make sure that I plug it in for x, but which equation I choose doesn't matter. I often suggest that you find the one that looks easier. To me, these both look like they would just be about the same amount of work. They're both two-step equations here. So I'm just going to plug it into the first. If you want to try it in the second, you're more than welcome. So my first equation, y equals 2 times x, I know that x is negative 4, plus 4. So I have y equals negative 8 plus 4. Y equals negative 4 should be my answer. So in this particular situation, my answer now is x is negative 4, y is negative 4. And you can pause the video here and try it out, plug it back in, make sure it works for both. Everything we did so far is your summary today. For your question tonight, I want you to try this one and have it ready to discuss with your group when you come in tomorrow. First equation is y equals negative 4x plus 1. Second equation, y equals 5x plus 10. Again, if they both equal the same amount, then they should equal each other. So take this value of y, plug it in for the value of y up there. You need to solve for both variables and then write your answer in an ordered pair. I'll zoom in a little bit. Oops, that's out. Just kidding. Zoom in a little bit so you can see it. Copy it down. Have that solved for when you come in tomorrow.